Lesson 8, Tuning. Best Practices. At least 50% of the time, conservatively, performance problems are designed into an application. During the design of the application and the related database structures, the application architects may not know all the ways in which the business will use the application data over time. As a result, there may always be some components whose performance is poor during the initial release, while other problems will appear later as the business usage of the application changes. The following best practices may seem overly simplistic, but they are violated over and over in database applications, and those violations directly result in performance problems. There are always exceptions to the rules because the next change to your software or environment may allow you to violate the rules without affecting your performance. In general, though, following these rules will allow you to meet performance requirements as the application usage increases. Part 1. Do as little as possible. End users do not care, in general, if the underlying database structures are fully normalized to third normal form or if they are laid out in compliance with object-oriented standards. Users want to perform a business process, and the database application should be a tool that helps that business process complete as quickly as possible. The focus of your design should not be the achievement of theoretical design perfection, it should always be on the end user's ability to do his or her job. Simplify the processes involved at every step in the application. In your application design, strive to eliminate logical reads. In the past, there was a heavy focus on eliminating physical reads, and while this is still a good idea, no physical reads occur unless logical reads require them. Let's take a simple example. Select the current time from Dual. If you select down to the second level, the value will change 86,400 times per day. Yet there are application designers who repeatedly perform this query, executing it millions of times per day. Such a query likely performs few physical reads throughout the day, so if you are focused solely on tuning the physical I/O, you would likely disregard it. However, it can significantly impact the performance of the application. How? By using the CPU resources available. Each execution of the query will force Oracle to perform work, using processing power to find and return the correct data. As more and more users execute the command repeatedly, you may find that the number of logical reads used by the query exceeds all other queries. In some cases, multiple processors on the server are dedicated to servicing repeated small queries of this sort. What business benefit? In your application design, strive to avoid trips to the database. Remember that you are tuning an application, not a query. You may need to combine multiple queries into a single procedure so that the database can be visited once rather than multiple times for each screen. This bundled query approach is particularly relevant for thin client applications that rely on multiple application tiers. Look for queries that are interrelated based on the values they return, and see if there are opportunities to transform them into single blocks of code. The goal is not to make a monolithic query that will never complete, the goal is to avoid doing work that does not need to be done. In this case, the constant back and forth communication between the database server, the application server, and the end user's computer is targeted for tuning. For reporting systems, store the data the way the users will query it. If you know the queries that will be executed, such as via parameterized report, you should strive to store the data so that Oracle will do as little work as possible to transform the format of the data in your tables into the format presented to the user. This may require the creation and maintenance of materialized views or reporting tables. That maintenance is of course extra work for the database to perform, but it is performed in batch mode and does not directly affect the end user. The end user, on the other hand, benefits from the ability to perform the query faster. The database as a whole will perform few logical and physical reads because the accesses to the base tables to populate and refresh the materialized views are performed infrequently when compared to the end-user queries against the views. Avoid repeated connections to the database. Opening a database connection may be a slow and largely avoidable operation. If you need to connect to the database, keep the connection open and reuse the connection. At the application level, you may be able to use connection pooling to support this need. Within the database you may be able to use stored procedures, packages, and other methods to maintain connections while you are performing your processing. Use the right indexes. In an effort to eliminate physical reads, some application developers create many indexes on every table. Aside from their impact on data load times, discussed in the Test Correctly section later in this chapter, it is possible that many of the indexes will never be needed. In OLTP applications, you should not use bitmap indexes. If a column has few distinct values, you should consider leaving it unindexed. The optimizer supports skip scan index accesses, so you may use an index on a set of columns even if the leading column of the index is not a limiting condition for the query. Part 2. Do it as simply as possible. Go atomic. You can use SQL to combine many steps into one large query. In some cases, this may benefit your application. You can create stored procedures and reuse the code and reduce the number of database trips performed. However, you can take this too far, creating large queries that fail to complete quickly enough. These queries commonly include multiple sets of grouping operations, inline views, and complex multi-row calculations against millions of rows. If you are performing batch operations, you may be able to break such a query into its atomic components, creating temporary tables to store the data from each step. If you have an operation that takes hours to complete, you almost always can find a way to break it into smaller component parts. Divide and conquer the performance problem. For example, a batch operation may combine data from multiple tables, perform joins and sorts, and then insert the result into a table. On a small scale this may perform satisfactorily. On a large scale, you may have to divide this operation into multiple steps. 1. Create a work table. Insert rows into it from one of the source tables for the query, selecting only those rows and columns that you care about later in the process. 2. Create a second work table for the columns and rows from the second table. 3. Create any needed indexes on the work tables. Note that all of the steps to this point can be parallelized: the inserts, the queries of the source tables, and the creation of the indexes. 4. Perform the join, again parallelized. The join output may go into another work table. 5. Perform any sorts needed. Sort as little data as possible. 6. Eliminate unnecessary sorts. As part of the example in the preceding section, the sort operation was performed last. In general, sort operations are inappropriate for OLTP applications. Sort operations do not return any rows to the user until the entire set of rows is sorted. Row operations, on the other hand, return rows to the user as soon as those rows are available. Consider the following simple test: perform a full table scan of a large table. As soon as the query starts to execute, the first rows are displayed. Now, perform the same full table scan but add an order by clause on an unindexed column. No rows will be displayed until all of the rows have been sorted. Why does this happen? Because for the second query Oracle performs a sort order by operation on the results of the full table scan. As it is a set operation, the set must be completed before the next Eliminate the need to query undo segments when performing a query. Oracle will need to maintain a read consistent image of the rows queried. If a row is modified by another user, the database will need to retrieve the earlier version of the blocks from the undo segment to see the row as it existed at the time your query began. Application designs that call for queries to frequently access data that others may be changing at the same time force the database to do more work. It has to look in multiple locations for one piece of data. Again, this is a design issue. DBAs may be able to size the undo segment areas to reduce the possibility of queries encountering errors, but correcting the fundamental problem requires a change to the application design. Part 3, tell the database what it needs to know. Oracle's optimizer relies on statistics when it evaluates the thousands of possible paths to take during the execution of a query. How you manage those statistics can significantly impact the performance of your queries. Keep your statistics updated. How often should you gather statistics? With each major change to the data in your tables, you should reanalyze the tables. If you have partitioned the tables, you can analyze them on a partition-by-partition basis. You can use the automatic statistics gathering feature to automate the collection of statistics. By default, that process gathers statistics during a maintenance window from 10 p.m. to 6 a.m. each night and all day on weekends. Since the analysis job is usually a batch operation performed after hours, you can tune it by improving sort and full table scan performance at the session level. The result will be greatly enhanced performance for the sorts and full table scans the analysis performed. Hint where needed. In most cases, the cost-based optimizer, CBO, selects the most efficient execution path for queries. However, you may have information about a better path. For example, you may be joining a local table to a table in a remote database, in which case you would want to avoid repeatedly querying individual rows from the remote table. You would most likely benefit from doing fewer retrievals of many rows from the remote database. You may give Oracle a hint to influence the join operations, the overall query goal, the specific indexes used, or the parallelism of the query. Part 4, maximize the throughput in the environment. Use disk caching. If Oracle cannot find the data it needs in the database, it performs a physical read. But how many of the physical reads actually reach the disk? If you use disk caching, you may be able to prevent 90% or more of the access requests for the most needed blocks. If the database buffer cache hit ratio is 90%, you are accessing the disks 10% of the time, and if the disk cache prevents 90% of those requests from reaching the disk, your effective hit ratio is 99%. Oracle's internal statistics do not reflect this improvement. You will need to work with your disk administrators to configure and monitor the disk cache. Store data efficiently at the block level. Oracle stores blocks of data in memory. It is in your best interest to make sure those blocks are as densely packed with data as possible. If your data storage is inefficient at the block level, you will not gain as much benefit as you can from the caches available in the database. If the rows in your application are not going to be updated, set the PCT-free as low as possible. For partition tables, set the PCT-free value for each partition to maximize the row storage within blocks. By default, each partition will use the PCT-free setting for the table. Set a low PCT-free value for indexes. If the PCT-free setting is too low, updates may force Oracle to move the row, called a migrated row. In some cases row chaining is inevitable, such as when your row length is greater than your database block's size. When row chaining and migration occur, each access of a row will require accessing multiple blocks. impacting the number of logical reads required for each command. You can detect row chaining by analyzing the table and then checking its statistics via user tables. The chain CNT column will be populated with the number of chained rows. Designing to throughput, not disk space. Take an application that is running on 8-9 GB disks and move it to a single 72 GB disk. Will the application run faster or slower? In general, it will run slower, since the throughput of the single disk is unlikely to be equal to the combined throughput of the 8 separate disks. Rather than designing your disk layout based on the space available, a common method, design it based on the throughput of the disks available. You may decide to use only part of each disk. The remaining space on the disk will not be used by the production application unless the throughput available for that disk improves. Avoid the use of the temporary segments. Whenever possible, perform all sorts in memory. Any operation that writes to the temporary segments is potentially wasting resources. Oracle uses temporary segments when the sort area within the PGA does not allocate enough memory to support the sorting requirements of operations. Sorting operations include index creations, order by clauses, statistics gathering, group by operations, and some joins. As noted earlier in this chapter, you should strive to sort as few rows as possible. When performing the sorts that remain, perform them in memory. Favor fewer, faster processors. Given the choice, use a small number of fast processors in place of a larger number of slower processors. The operating system will have fewer processing queues to manage and will generally perform better. Use partitions. Partitions can benefit end users, DBAs, and application support personnel. For end users there are two potential benefits: improved query performance and improved availability for the database. Query performance may improve because of partition elimination. The optimizer knows what partitions may contain the data requested by a query. As a result, the partitions that will not participate are eliminated from the query process. Since fewer logical and physical reads are needed, the query should complete faster. Use materialized views. You can use materialized views to divide the types of operations users perform against your tables. When you create a materialized view, you can direct users to query the materialized view directly, or you can rely on Oracle's query rewrite capability to redirect queries to the materialized view. As a result, you will have two copies of the data, one that services the input of new transactional data, and a second, the materialized view, that services queries. As a result, you can take one of them offline for maintenance without affecting the availability of the other. Also note that you can index the base table and the materialized view differently, with each having the structures needed for the specific data access types it is intended for. Use parallelism. Almost every major operation can be parallelized, including queries, inserts, object creations, and data loads. The parallel options allow you to involve multiple processors in the execution of a single command, effectively dividing the command into multiple smaller coordinated commands. As a result, the command may perform better. You can specify a degree of parallelism at the object level and can override it via hints in your queries. Part 5. Test correctly. In most development methodologies, application testing has multiple phases, including module testing, full system testing, and performance stress testing. Many times, the full system test and performance stress test are not performed adequately due to time constraints as the application nears its delivery deadline. The result is that applications are released into production without any way to guarantee that the functionality and performance of the application as a whole will meet the needs of the users. This is a serious and significant flaw and should not be tolerated by any user of the application. Users do not need just one component of the application to function properly, they need the entire application to work properly in support of a business process. If they cannot do a day's worth of business in a day, the application fails. Do you want to learn new skills in the fastest and most effective way? Visit learnwithvideotutorials.com.